distributed systems, which are scalability, reliability, and availability. In this video, I'm going to talk about a few of the terms they are frequently used in designing distributed systems, and they are very important also. The first one is the CAP theorem. So CAP, there are three words in this. CAP, C stands for the consistency, A stands for availability, and P stands for the partition tolerance, which is related to network breakage. So if we think about partition tolerance, it is difficult to avoid. Network packets are going to drop, and we cannot completely avoid partition tolerance. So CAP theorem actually says that you can have any two of them at a time. You cannot have all of these properties in a distributed system. So for example, you can have either the CA system, AP system, or the CP system. But as I was saying before, that partition tolerance is difficult to avoid. So partition tolerance would be there. So think about that either you can have the consistency or availability, because partition tolerance is going to be there. So we have the system, either the CP systems or the AP systems, because P is there in every case. So if we talk about the databases, traditional databases, they prefer consistency over availability. Like if you talk about Oracle transactional databases, so at any point of time, any instance of data at one node would be 100% consistent to the other node. So those are consistent systems. But NoSQL databases actually prefer the availability over consistency. So for example, we use Facebook. So if somebody like your pictures or video or something, it might not be reflected in the count. Let's say you have the 100 counts right now and somebody likes 101, could be after some time, and on the other node it could be 101 after a few times. So but eventually it would be that count. So that's what is the eventual consistent, that there are two instances of data, but eventually they would be finally consistent. So that is called the eventual consistency, and the NoSQL databases actually support that. The second thing about distributed system which comes into my mind is the partition of data. So if you have a internet scale data, let's say the Facebook database, we can talk about there are millions or billions of users. So how those users data would be saved in Facebook infrastructure. So of course it cannot be saved in one single node. So we need to divide the data. So when it comes to the dividing of the data, then we call it the sharding. So imagine if you have a very large table like this, you have the rows and columns like this, and you have user ID and email and address or email. I mean, you can understand that there could be different fields here. So instead of having billions of users in a single table, if you can divide that a set of users or a set of rows into the different nodes. So we call it the shard 1 or shard 2. So basically sharding is nothing but it's a horizontal cutting the table like this. So this part would be saved in the different nodes. So that is called the partitioning of data. And whenever it comes to dividing the data, we can talk about the sharding. And there's another term people use, consistent hashing. That is another good technique which solves other problem which are there in the sharding. We can talk about later, but keep that in mind, that consistent hashing is nothing but it's a technique to partition the data. Third thing, I want to talk about the kind of databases we use based upon our use. So we all know that we have two kinds of data. Basically, one is the relational database, or the tabular we call it, and the other is the NoSQL databases. So relational databases, they are they provide the ACID properties. ACID is atomic, consistent, isolated, and durable databases. And the NoSQL, they are the different kind of there's an acronym people use, the BASE. So base is nothing but the basically available solid state eventual consistent database. So so ACID and BASE are the two characteristic we recognize relational with the ACID, and the BASE with the NoSQL databases. And there could be variety in the NoSQL databases depending upon the uses. So we have the key value database, we have the white column database, and another could be the doc based, and the fourth one is the graph. So key value database is used where you want to have the, think about hash table kind of thing, where you have a unique key for the record and you have the value itself could be another key value pair. But the idea is if you really want to access the data very fast, lookup should be faster. In that case, we use the key value database. And another one is the white column database in the NoSQL, where you can have the white columns or set of columns used in the data in the table, which is not possible in relational without changing the schema. So that is also one of the good advantage of NoSQL versus relational, that if you really want to change the type of, or the logical schema, or any, if you want to add a column, you have to change the schema and change the whole thing. But here in the NoSQL, that schema changes are not required. You are not very much tied to your schema changing thing, and you can change the things on the fly. So white column is catered to that kind of needs. Doc based are when you have the semi-structured data, semi-structured like JSON file or the XML data, then you can use in the doc base. So like CouchDB, MongoDB, all those kind of, you have heard the term, those are examples of the doc based document based databases. So graph is when you think about entities and their relationships. So one of the good example is think about Facebook. We have the people or entities, and they are related with each other. They are friends of each other. So relationship is the friend. So whenever you have a lot of nodes, and you want to know the relationship, and you can connect them with certain kind of things, so graph databases are used in that case. So Neo4j is one of the example, and there are other databases for that. So roughly there are two categories of data, relational and NoSQL, and NoSQL has these four kinds of things. We have to keep that in mind, and what kind of database is used is based upon entirely on the how we want to use the data. So different systems have the different needs, so we use accordingly any kind of NoSQL database. So this is third, and the fourth point I want to talk about is the caching. I touched upon in the previous video also. So caching is used to speed up the reading process, and the idea is to, if you have, um, if you have read something recently, you should be able to access from it from the cache rather than going to the database again. So it speeds up the process, performance, latency, and all other things. So caching solutions are ready-made solution. Memcached, people use Memcached, and the other one is the Redis. So Redis have a lot of other things. Redis clusters can be formed, but the bottom line is, if you want to speed up the performance, read or write, you put the cache in front of client or in front of users, and between the actual server, database servers. So it speeds up the reading process. Another thing comes up is the DNS lookup. DNS is very important part. If we have a client and client wants to access, let's say www.xyz.com. So first the request actually, and the server, how it knows that that the server's IP address and other things. So before it goes here, actually it goes to the DNS server, and DNS server actually looks at the xyz.com and finds there's a different set of server it goes to, and finds some IP address, 32-bit address, and return back to the actual client, and then client knows it by the IP address, and then it goes to the actual server. So before accessing the service, you need a DNS lookup, and that's a complicated process. It goes to the different servers, set of servers. There are 2 or 3 levels actually, but we don't want to be interested in that kind of detail. But just understand that DNS lookup is when the alphanumeric website address goes to the DNS server, it returns back the IP address, and through that IP address, client accesses the actual server or the service. Another point is a CDN and the edge. CDN is content delivery network. Last video I talked about that it's a kind of caching mechanism. So you use the frequently accessed data into the different geography, mostly the static data, like Netflix uses it for all the video files, frequently watched shows. They are onto the content delivery networks in each geography, and so it's a caching mechanism. And edge is something when you put processing of the nodes near to the user's location. So what is the advantage of that? So edge nodes advantage is that you can do the processing at the edge or near where the user is located, and then that data can be transferred back to the actual data center, and there are dedicated lines to that. So it makes the overall process faster. So edge location, so processing is very important, and it is done at the edge locations in that case. And there are different kind of data structure. I would say that Bloom filters, and there's another count min sketch. Sometimes we use that if you have to. So Bloom filters are probabilistic kind of data structure. They might give you false positive, but never gives the false negative, and they saves a lot of, if you want to see that certain data set are there in the actual set of data. So in that case, we use the Bloom filters. And count min sketch is also a very good data structure, where let's say you have a very lot of data coming up, and you are only interested in top k elements, or top k data items. In that case, using less amount of memory, you can track all those k items. So count min sketch is used in those kind of situations. So these data structures are very space efficient. That's why we use them. The next thing I want to talk about is the map reduce. Also in the batch processing we use whenever you have big data and you want to do a lot of processing. So distributed parallel processing can be used through the map reduce paradigm. It was coined by the Google, and then a lot of companies, Yahoo and others, they capitalize on that. And so map part is when you have the big data, you kind of sort that, you kind of filter that, and reduce is kind of you assembled all the data. So map reduce is so it is used in the batch processing actually, when you want to do certain things in the batch, then you can use the map reduce. Another thing we use in the text searching, so Elasticsearch is these days we use a lot of log data and other things, and so full text search whenever you want to do the certain keywords or something, so we use Elasticsearch, and sometimes we use the Solar also, and they both are based on the same technology, I guess. And the last term is the data storage. Where do you want to have store the big files? So data storage, or we another term we use the blob storage, where there's not much change in the data, like video files, audio files, and sometimes some other kind of data can be used. So data storage or the blob storage is the one and same thing. And one example of that is Amazon S3, or Google Cloud Storage. So so these are the things actually we use in the distributed system design. We started with the CAP theorem, talked about the consistency, availability, and the partition tolerance. Then we talked about partition data and the sharding, and consistent hashing is also used because sharding has some other issues, like if you have a lot of hot data on one node, then that node would be overwhelmed, and we can solve that problem through the consistent hashing, but that is the topic for another video. And third thing, we talk about the kind of databases, relational and NoSQL. NoSQL has the 4 kind of databases. Based upon the usage and the need, we use all these 4 kind of data. Caching is used for speeding up the reading and the writing process. Then we talked about the DNS lookup, that how the alphanumeric address would be changed into the IP address. CDN and Edge CDN is a kind of caching solution. Edge is when you do the processing at the where the user is located. Bloom filters and count min sketch are the space efficient data structure. Map reduce is for the batch processing. Elasticsearch is for the full text search in the logs. It is frequently used. Solar is another solution, and they all are saved on the Lucene technology, and underneath technology the Lucene. And the data storage, we talked about the blob storage, Amazon S3, and the cloud storage are examples of those. Yeah, so I think that's enough for this video, and In the next video, I would be talking about some of the terms like what are the problems to be solved with the scalable system or distributed systems, like how do we solve the parallel request problem, how do we solve the problem of data hotspot, geolocation, single point of failure, and the data scaling itself. So that's all for this video, and see you next time. Thank you.